Hey, welcome back. Good to see you again. Hope you're all well. Thanks for joining the channel. Guess what I got on my bench today? It is a Hitachi SR-2004. Now, Hitachi entered the monster receiver wars too, and this is their contribution. This thing's a beast. You want to blow a spine out, pick this thing up, throw it around. This is a client unit. He brought it to me. He says it works fine. Absolutely fine. He's got no problems with it whatsoever, but he wants the full gamble done because he told me this is going to his grave with him, and he wants this thing to perform for the next 40 years. No problem. So we're going to do that. He says cost is not an object, and I kind of laughed, but that's the wrong thing to say to a tech. But we're not going to abuse that. We're going to do this thing proper. So we're going to do full recap. Yeah, like he says, it's fully functioning. He has no problems with it, probably aside from maybe a dirty control or a switch. But he says it's all working. So it's good that way. We don't have to troubleshoot anything. He just wants it restored, which is fine. We're going to do that. But I was kind of hesitant in putting this on the bench. Well, it dominates my I have no room whatsoever for anything on my bench. It takes up the whole thing. This is why I need a bigger bench. If people keep bringing me monster receivers, I'm going to have to do something about that. Or either turn them down. I don't want to do that. But, yeah, we're going to get into this. And this thing is really nicely optioned out. Let's have a look at some of the controls and features. Alright, on the left-hand side we have two power meters, left and right. And it goes up to 600 watts. That's really unusual that they would have it that high. This thing's rated at 200 watts. A channel into 8 ohms, I believe. Probably a lot more under 4 ohms. So, you know, knowing Hitachi, they probably put their best silicon in here. 600 watts, probably close to achievable. Maybe if you get a 4 ohm load or less. But we're not gonna try that out. Chunk power button. You can tell it's got a meaty feel to it. Switches a lot of current. Headphone outlet here. We have our bass, treble, and mid-range controls, and they are all detented and they have a nice feel to them. And then we have a defeat switch here and a defeat switch here, which we can set this to defeat and defeat, and this should be all flat. Or we can have a roll off of 150 Hertz or 300 Hertz. So if we want to boost or cut low frequencies, 150, turn it down. If we want to boost or cut higher up in the band, we can do that as well. And this here, we can switch between 3 kilohertz and 6 kilohertz for our hinge on the treble side. Speakers, switches for 3 sets of speakers, but if I probably only have, these are probably interlocked so that only 2 can be on at the same time. A protection lamp here. So this is going to have some protection circuitry in it, obviously. And that probably comes on when we first power it up, and then it goes off when the relay clicks, I'm assuming. And then if we have any fault conditions, that will click off the relay and this lamp will come on. So that's all about. In the center here we have a balance control. Pretty self-explanatory. We have a low filter, high filter for our audio path. We have 2 levels of audio mute. We can go minus 20 dB or minus 40 dB. This thing's loud, so I'll probably use the 40 quite a bit. And we don't have a volume control. It's called a level attenuator. So they must have an attenuator in there, and it's got a nice feel to it. A really nice clicky feel. No multiplex noise filter for FM. FM mute, auto lock on. We can select between wide and narrow IF band on the FM IF. And then we can FM multipath switch on or off. I don't know what this does to the circuit. Must do something. Multipath. We got tape monitor switches here. We have 2 tape monitors, 1 and 2, source, and then we have our copy switch. We have 2 to 1 or 1 to 2, depending on which way we flip that. Nice function switch here. We got AM, FM, phono 1, phono 2, and auxiliary. So we got 5 positions there. Is that loose? Well, maybe not. Stereo mono switch, loudness switch, and adapter on and off. This is probably for a Dolby adapter, and this is probably like an extra tape monitor switch. You would probably put something in here like an equalizer or some other device, and you could probably use that as your third tape monitor switch, I'm assuming. I haven't even looked at this yet, so don't quote me on that. We have microphone input, 1/4 inch jack for that, and then we have a mixing switch. Switches it on, and then we can turn up the volume for a mic if you like doing karaoke night, and then a tuning. Here we got a signal meter and a center channel tuning meter, which is nice to have on an FM. Dyna Harmony. I wonder what they were trying to get with that. Dyna Harmony. Is that like a trade name or something? Okay, in the back panel we have our inputs, phono 1, phono 2, and auxiliary, and a ground. We have tape 1 loop, and it also has a DIN connector for tape 1. Tape 2 loop, right here. And then we have our external adapter loop in and out. So this could be used for another tape deck if you really wanted to, or any kind of adapter you had in mind you want to connect. FM multipath, horizontal and vertical output. So we could connect a scope to these, and we could scope out the FM multipath on XY mode. We have a bar antenna for AM, okay, and we have 75 ohm FM input, 300 ohm FM input, AM long wire input, and we have 75 ohm input on the FM here as well on binding posts. And then we can clamp our coaxial cable, connect it to the 75 ohm input. That's our ground. Should tighten that down. Don't want to lose that piece. On this side we have 3 speaker outlets, and we have our preamp out, main in jumpers for left and right channel, and we have 3 courtesy outlets, 1 switched and 2 unswitched. I don't see any voltage selection on this. Don't see anything like that. But let's look at the terms of agreement here. Speakers A or B or C, A plus B or A plus C or B plus C. We can be, A or B or C, we can have 4 to 16 ohms. And then if we start teaming them up together, it has to be 8 ohms or more. So they're not recommending 4 ohms in parallel speaker configuration. And here's our model number, SR-2004, Hitachi 1020 volt amps, or 850 watts. Somebody's been fooling around here, because this is a clamp that's supposed to be hooked on this top of the lid, and it's down. And same with this side. Somebody's had this one out loose, and it's supposed to hook into there to hold the top lid. So anyway, let's get the top lid off and have a look inside. Okay, I hope I got the camera far enough back so I get this all in frame. So it's got 2 lids, 1 steel and 1 wood. This looks like a vinyl wrap on plywood. Yeah, so let's pull the back one off first. And we have, this is all amplifier back here. Big toroidal power transformer, 125 volt, 10,000 microfarad. Ouch. And then we have a smaller set of caps here. And these, I can't read. These are 63 volt at 18,000. Okay, so they're using some kind of a dual supply here, I think. I don't know. Power amplifier cards. Everything looks good. Looks like it's all like plug connectors. We can just easily take out one module and service it, and the other. So let me get rid of this lid. Let's pull the other half off. Wow. And we expose the rest of it. I'm assuming this is all tuner under here, because we have tuner front end, tuner IF, I'm assuming, I don't know. This is a switching card back there, all switches, more switches, that's our speaker selector switches. And then, yeah, so this is that card I was telling you about, 3 relays for the speaker outputs. Power amplifier. And we have 4 devices per amplifier, which means they're doing tandem outputs. And it's 2 SB722 and 2 SD752. These are original Hitachi devices, so that's all factory. And yes, this is a tuner. I can see tuner-like stuff underneath there. It's never seen any servicing. I don't see anything here that looks like it's out of place or been touched. Looks all factory original. So, let's get the bottom off, have a look under there too. You can tell somebody's been in here already by the screws, or kind of the Phillips socket of the screws kind of stripped open. Alright, here we are. Wow, there's a lot going on here. So this looks like it's all tone board, volume attenuator, looks like somebody's been soldering on here. Maybe they've had it out, I don't know. This here could be phono stage, but I'm not sure. It probably is. It's got some relays here. And then this here looks like it's probably protection. And then we have power supply under here. This is kind of cooked under this heat sink here. There's a lot of power resistors. There's 1, 2, 3, 4, 5, 6, 7 power resistors in a row here underneath. And it looks like the board's a little cooked. So then all these capacitors are filters for the power supply. This is like a soft start circuit, it looks like to me. Big power resistor, relay, cap for timing. So that's probably what's going on there. Got the underside of our power supplies. Looks like we have a bridge rectifier for each side. And then the caps. And this is a big ass fuse. You've never seen a big ass fuse like this before. Let me pull this out. Where would you find one of these? Oh man. I don't think they sell these at DigiKey. It's huge. 15 amps. I don't know if that's the correct size. Snaps in there. So yeah, this is all input, AC mains input right here. Power switch goes up here, so they got the wires running. So that's no problem. And then we have soft start. This is on the main primary side as well, because we have these black and white wire coming down to terminal strip, and this is all soft start with a couple fuses. And then power supply for each channel. Yeah, it's going to be interesting. He says it works perfectly. I says, well, I'll probably find something wrong with it. You know, I always do. So let's get started on this. I'll remove the face so we don't damage anything, all the knobs. And then we'll start with our recapping and our visual inspections. Okay, I guess before I tear into it, I should at least test it. See if there's any weak spots, any bad switches or pots. So I got it plugged in. It's turned off or consuming 0. Let's turn this thing on. Speakers are connected. Let's go. Jumped up to over Oh, there's one click. Jumped up to over 300 watts, and it's settling around 85 watts consumption. And looks like we have all our lamps. That sounds all right. Let's turn on our speaker A. Oh, they got a little LED. Speaker A, speaker B, speaker C turns them all off. Yeah. So I thought, okay. Oh, I can hear distortion in both channels. It's probably relay. Let me bang on the relay. You can hear it in the right channel. You hear that? I don't know if you can hear that distortion. Sounds terrible. Doesn't banging on the relay doesn't seem to fix it. Oh, there we go. Something on the tone board is so we might have just a cracked solder or something on the tone board. Or maybe one of these switches need cleaning. Okay, let's try 401, 402. It's 402, 401. Sounds okay. Okay. FM. We've got muting. Seems to be working okay. The dirty tuning capacitor's dirty. Alright. So it sounds like we got a little bit of problem on the tone board. Everything else seems fine. Okay, I'm going to tear into this and start ripping it apart. Okay, I think I'm going to start on the tone board here. I'm going to remove the tone board by removing all of the fasteners in the front. It should come back and out. All these bodges here, all these resistors, I like to remove these. This is a 10K resistor, and here's 470K, 470K. I like to remove all those and just put a surface mount chip resistor in its place, just so you don't have this bodge anymore. It's there, but it's not going to look like that anymore. It's going to look a lot cleaner. And I'm going to do that for all of these bodges, except for ones I can't. This one here might be tough. I'll figure something out. This one too. But this one I can remove, these ones I can remove, these ones I can remove. And I think that helps a lot with tidying up the circuit board. Looking at the bottom here, I don't see any cracked solders yet. But there was obviously a problem on this board because our channel dropped out. or is distorted. Doesn't look like, I don't know, the way they tied their harnesses together is kind of, either somebody's been in here snipping cable ties, or they didn't do a very good job of cleaning up their harnesses. Somebody might have been in here. You can see one, oh, maybe not. But these have no connectors, so this is going to be a little bit of a challenge. This all has to be remain connected, has to slide back and out. And then this power board here, this long board here, it's going to have to come out as well. Those go through a hole, and then so this might be a real challenge to do this board here. I'll see how this one goes first, and then we'll start there. All right, that was a little more involved than I thought. I had to remove the switchboard that was above it because these wires, these 4 wires here, are so short you can't back the main tone board out without this one coming with it. So I just removed all those screws from the switches, and they come out as well. And this is all saturated with oil, like somebody was spraying in contact cleaner or something, and there's oil everywhere. These are all wet with oil. Caps are wet. Looks like somebody just hosed it out from above. So yeah, I'm gonna have to, a lot of these potentiometers I'm not gonna touch because they sounded fine when I tested them. I'll leave them alone, and they're all saturated with oil, so leave them alone. The switches, though, a different story. I'm probably going to have to remove these switches, disassemble them, and clean them. This one here is the function switch. 1, 2, 3, 4 wafers on it. Once I get it out, it's easy to clean. This is all oxidized and heavy, black oxidation. And then these switches here, I don't think these were problematic, but I'm going to go and check them anyway. I still have to access these caps in here, so I'm just going to start with recapping, and then we'll continue on with switch cleaning. So I just started pulling switches apart, working on switches. This actually looks pretty good. I'm thinking if all the switches are like this, I'm just going to take them apart, and I'll skip the polishing step because that's kind of aggressive. That removes material. Probably what I'll do is I'll just clean it with a swab and some cleaner and just re-lubricate it with some deoxit. These things were saturated with oil inside. This whole board is pretty much flooded with some kind of a spray that had oil in it. And I have a feeling, I know it's the D5. I don't know for sure, but I have a feeling. So I'm going to put this back together with a little touch of this, and yeah, this will be a little quicker than I thought, so that's good. This switch here came out easy. This one desperately needs a clean. You see all, I don't know if you can see inside, it's all black. All the contacts are all black. What I'm going to do is maybe disassemble the switch and clean it really good. And then this won't give you any troubles for 40 years if you do that. Take it apart and clean the oxides off, and give it a little bit of treatment. The recapping of this board went well. Not much to say about it. I did replace 8 transistors on this board. These are the 2SC1345s, and I put in KSC1845s. So 8 new transistors. I don't know, quite a few caps on this board. Caps are starting to show a lot of age. They're failing really far out of tolerance, a lot of high ESR. So it's a good thing we're doing this. This is going to be a good thing for this receiver. I also removed bodges. I still have 2 to do. I removed all these bodges down here and used surface mount resistors, so you can't even see them now. And there were some other ones. Oh yeah, over here, removed these bodges and replaced them with surface mount resistors. And I'm going to do that all throughout the receiver. It really cleans it up and makes it look a lot better. Easier to work on too. Alright, so here's a look at the contact resistance. This is the soft start relay. Okay, here we go. 6 milliohms. 5, 6. This thing's perfect. I'm going to put that back in. There's nothing wrong with this relay whatsoever. Alright, I was cleaning these switches and I figured maybe I should turn the camera on. Maybe you guys like to watch too. Yeah, these are all saturated with some kind of oil. That's why I got gloves on, because it's all over my hands. Some kind of a lubricant or something, I don't know. So these have these tangs that are spread open. You just got to take a pair of nippers and close them up. Don't go crazy, just close them just enough so that you can slide the bottom off. And we'll do this one. Be very careful with these because they will snap, and you can only do this maybe once or twice and then these will break. This steel does not like being bent and then bent back. It wants to crack right away. I think I got it. This one has to go up some. And so is this. No, it's all good. Okay, I usually put the switch in the center position and then slowly ease this off very carefully. And it wants to all come out at once. There we go. Yeah, that's what I mean. You see how wet it is inside? This piece goes in here. Put that back. Might have to align it later. Okay, this is what we're working with. Now you can see they're not oxidized that bad. There's a little bit of tarnish on them, but for the most part they're pretty clean. I think the lubricant helps in keeping the oxidation away. Just going to remove these. And then we can just... Ooh, that's what got away on me. This one has some kind of green slime in it. Anyways, I'm going to use contact cleaner and I'm just going to soak down. We're going to use this to get rid of all the old lubrication and any of the dirt. Whatever lubrication that was in there is starting to dry up and get kind of, I don't know, it kind of solidifies. See, this one's saturated already. Let's get a new one. If these were black, like I've seen before, you can just get polish and polish this. This is silver plated copper, and yeah, look at how the second cleaning took off more. And give it a third cleaning. Why not? If you go crazy with polish and start removing too much silver, you'll break through to the copper, and then your switch will not perform very good at all. Okay, let's leave it at that. Get another one and dry this. Just going to dry it. Okay. These things, I usually inspect them if they're fairly clean inside. Sometimes you get the old lubricant gets caught up inside and it turns into a lump of grease or a lump of sludge inside. You might have to clean them. But these ones are good, so I don't do anything with them. I just put them back on. Be very careful, they're very fragile. Slide it out. It was in the center, I believe. So I figured I might as well turn the camera on. I know some people tune in just to watch me clean switches. There must be something behind that people like. I don't know. Maybe it's a calming effect. Who knows? So we line them all up so that they're in the center. Now let's look at this. Where are my tweezers? I usually don't do anything with this part because this is already lubed up. It's doing pretty good. Okay, let's get rid of some excess here. So this little thing here has to fit into this or this. I think it fit into that one. So let's try it. Yeah. And then just check its range. It's working. Okay. Now this has two different cutouts here. We got this cutout and this cutout. So this side will fit on here. This side fits here. So you can't really screw it up and put it in backwards. But you got to make sure that when you're putting it together, you don't crush those little copper colored spring things. So they just want to drop into place. And don't force anything. Just kind of wiggle it back and forth and it'll drop in. Just like that. No force. We're good. Oh, you know what? I forgot something. Take this apart again. I'm going to treat this with some deoxit. I'm going to use the concentrate. It's a little drop on each one. This will keep oxidation from coming back. Especially in the contact area where it matters the most. Just a little bit. I don't want to get carried away. This is together, and that's correct, so flip this over. Okay, last step, close it up. Just get a flat screwdriver and bend these back. Don't go crazy. It's a little bit loose. That's okay. I think you want a little bit of play between the housing and the printed circuit board, because if it's rigid and you have any movement within the operation of it, you'll crack these solder joints if it's all rigid. But if you have a little bit of play, like that's a little bit of play there. It's not completely tight, so that's good. I think it helps. Okay, then I look straight on this way, and I see, where's my pliers? If any of these need to be straightened out. Alright, that switch is ready to go back in. And it should work like a brand new switch. I got one more to do, and then I'm going to put these in. So I'm looking at the wiring of this thing, and I'm just like, really, Hitachi? This is your flagship receiver? Really? It looks like it was assembled in a hurry, and then they stuffed They have cable ties back here, here, and they stuffed all the, you know, they did it in a hurry, and this is terrible. This is awful. The way this is just bodged together. And looking at this board here, this entire board has to come out. Well, not out, but it has to flip out so I can at least work on it. This thing's just loaded with caps, and it's loaded with those transistors that need to be replaced. So I have to get to the back side of this, but I can't because all four sides of this board have connectors that are wire wrapped on it. So I may have to just cut all these wires here from the power. I think I should be able, if I cut those ones, these ones here, I should be able to flip this board out this way enough to get in behind and get my soldering iron in there and do all the work I need to do. But this is ridiculous. And I'm looking at these wires they're using are a joke. Like these are, okay, these coming from the transformer's right here. These are all 18 gauge, okay? But these wires here, some of these are 20 gauge. And I thought this was a 200 watt amplifier per channel. This is like a 20 gauge. Where does that go? That goes to the power board. And then some of these wires sneak up to the top and then they plug into the amplifier modules. And they are no better than 20 gauge, I don't think. What is this red wire here? Let's get an example. Let's pull this red wire out. This red wire connects between this bridge and this capacitor. What the hell size is this? 18 gauge. Well, that's okay, I guess. But you know, you'd think a 200 watt per channel amplifier would have more stout wiring. I think this is kind of pathetic. We got all this wiring that goes up to the power amplifier here, and it comes from all over the place. Anyways, enough of my ranting. I'm gonna have to get this board out somehow. This board's finished. All the switches are cleaned, treated, and put back in. I just need to solder them all back in. I haven't done that yet. I just tacked them so they don't fall out. I got a lot of the bodges removed. I still have 2 to do here. I gotta get rid of these bodges. And then I'm gonna focus my attention on this thing. I know this relay's bad. I think that was the cause of a dropped out channel when I first did a test. I think it's this relay here. That is the speaker protect relay. And then on the other side there's 3 relays for speaker switching. But all these caps are probably baked. Okay, I was able to disconnect. Actually, I disconnected 15 wires from along this side, and that affords me enough space that I can flip the board up and I can actually work on it now. And after inspecting it, there's a lot of cracked solders here around these power resistors and these transistors and stuff. This all has to be reworked. But what I'm going to do right now is I'm going to remove this heatsink and these power transistors and get them out because they're in my way. And then I can focus on recapping and checking components. And then we'll start here on the bottom with this power supply section. And then I'll work my way up the board. Got quite a bit of caps on here. It's going to be an all-day job. And then I got a lot of transistors up here that need to be replaced. Some down here. Yeah, they're all over. And let's go through this board. It's probably going to take me all day. But first step is remove this heatsink and these 3 transistors. Alright, here's a look at the main protection relay, speaker protect relay. Now it's got an oily residue inside it. Somebody was spraying something and got, I don't know if it was intentional or unintentional, but this thing has oily all over its surfaces. You can see it there. But I did test the contact resistance, and we are up in the kilo ohm range on contact resistance, which tells me these contacts are coated with something. So I'm going to open this up and polish these contacts. This is a unique relay. It's got 2 high current contacts in the middle and then the smaller ones on the outside. I think they make contact all at the same time, I'm not sure. But I'm going to clean this, polish these up, and then we'll get this back in order again, because I think this is the reason why when I did my initial test, I had one drop channel, and I think this explains it. Yeah, you don't ever spray anything inside a relay. It's not going to help. Alright, pulled out the power switch because just like everything else, it's all saturated with some kind of oil. The crazy spray can guy just flooded everything in the front here. Now, I checked the contact resistance on these two contacts and it seems okay. I think it was, let me check it again, I think it was like 3 milliohms or something. Let me try one more time quickly here. I know you guys are impatient. Okay. Yeah, I got 2 or 3 milliohms, and then when I open it up. Now, but there's another set of contacts here, so why don't we use those too? This one here measures about 20 milliohms, but those have never been used before. What I want to do is somebody sprayed oil, something oily inside the switch. That is a big no-no in my books. Don't do that. So what I'm going to do is I'm going to flush it out with some zero residue contact cleaner. This stuff will attack the oil that's in there and flush it out, and it should leave nothing behind, or a little behind. So I'm just going to flood this thing. And just let it, you can see the stuff that's coming out is kind of a yellow-brown color. Give it another one. Yeah, see all the gut coming out of there? I really don't want to open the switch if I don't have to, but yeah, I can see something's coming out. Now what I'm going to do is leave it dry like that, and what I'm also going to do is add some jumpers to bring this set of contacts into play as well, and then we'll be using both sets of contacts, and this switch will last indefinitely, or it should. The problem with these receivers that have power outlets on the back, switched power outlets in the back, is everybody loves to plug all that kind of stuff in there, all the other auxiliary equipment, and then turn everything on with one switch. Well, that's putting a heavy load on that one switch, and it shortens its life. That's why I don't much care for switch power outlets on the back of receivers and amps, because I think they're not abused, but they're overused. Let's give it one more treatment. Okay. Yeah, it's still coming out. Alright, so I'll get some jumpers wired across this contact. This is normally closed. This one's normally open. So when you push the switch in, these two are connected. When I let the switch out, these two are connected. So I won't use this one. I can actually just cut it off because it's just going to be in the way. Let's cut this one off. And then I'll just wire some jumpers across. Alright, there it is. I got my jumpers and I got these contacts bridged now. So that's going to drop the contact resistance and extend their life. So let's check the resistance now. I think it was like 3 milliohms before. What do we got now? Yeah, we still have 3 milliohms. 2 or 3. So we're doing pretty good. I'm going to put this switch back in, and then we'll move on to something else. Alright, so I'm making progress here. Just about pretty much everything under here is complete. These 4 boards, there's 2 underneath here that you can't see, they're all done. And removed all the bodges, replaced all the caps, cleaned them. Now the only thing left to do is I have to reattach all my wiring. I have 15 wires to connect, and that should finish everything under here. And then I'll flip it over and we'll start on the power amplifiers and tuner, and then we're getting close to being done. It's a lot of work in this thing. Alright, just removing the power amplifiers. They come out as a module. You got 2 screws on the back, 1 screw here, and there was 2 screws somewhere else. 2 screws on the side. And it just comes out, a couple of connectors. It's all in plugs. So I'll service these separately. Now, I checked these capacitors. These 2 here are 10,000 microfarad at 125 volts. They test absolutely fine. They're right up at 10,000, even higher than 10,000. They're right on spec. These 2 here are 18,000 at 63 volts, and they are not up to spec. They are down around 13,000 microfarad. Now, my plan is to replace these 2 and leave these 2 in place and run with these and replace these. I can source a 22,000 microfarad at 63 volts, same can size, exact same can size. So I'm probably going to order those, get those in, and I'll replace these. Everything else is fine with the power supply, just needs cleaning. Around here it's all very dusty. Tuner, got full access, I'll do that. And then I'll remove these 3 speaker relays and clean these up. I don't think anybody sprayed anything into these ones. These look dry, so they might be okay, but they're going to get cleaned regardless. And then that's going to be it. I'm going to be finished pretty soon after the tuner and the power amps. So I'm going to go place an order, and next week our caps will arrive and we'll put those in. Alright, let's have a look at the power amplifiers in this receiver. Hitachi classifies this as Class G, and they have a special name for it. They call it Dynaharmony output circuit, which is their name, their coined name for Class G amplifier. So what they're doing here is they're providing 2 levels of power supply for the amplifier. And the reasoning is, for the most part, you listen to music, it's at a low level, and so what happens when you're listening to music at normal levels is this amplifier only operates on part of the circuit. You could take this here, and where is it? Let's see if I can do this. And this here, and remove that, and you have just a regular Class AB amplifier. You got plus 40 volts on this here, goes through your output transistor to the load, or you have your negative 40 volts on this line through your transistor, and you have your drivers for that transistor. So in normal, when your normal listening levels, this is all active and it's operating as a normal Class AB amplifier. Signal's coming in, it goes through the drivers, goes to the outputs, and then to your speaker. Now they're using plus and minus 40 volts as this for this level, and this will only supply so much power, but Hitachi wants more power than that. So what they did is they stacked transistors on top and bottom, and they gave it a higher voltage power supply. Here we got plus 98 volts, minus 98 volts. So what happens is when the music gets louder and this hits a saturation point where you can't get any more signal out of your speaker because you're hitting the rails, these kick in, and these will supply power for the extra output. What they're saying is less than 2% of the total music signal is used for doing peaks, and to make a dedicated power amplifier that has that much power on reserve all the time consumes a lot of power, because if you had for example a single amplifier, let's draw it out here, and this is plus 100 volts, not 1000, and minus 100 volts, and this is your speaker. If you had an amplifier that was designed to do the same power using single devices, you'd have to have plus and minus 100 volts on your rails. These transistors would have to be pretty incredible to handle that kind of voltage plus that kind of current. Also, you're going to have your idling current. So plus and minus 100 volts, and you have 50 milliamps idle current. That comes out to what? Let's see. So we got 200 volts times 0.05 equals, you got 10 watts of power between these two devices being dissipated up in heat. Using this, we only have 80 volts times 0.05 equals. So this is going to dissipate 4 watts here, and then instead of 10 watts at idle, it's going to dissipate 4 watts, which is a huge power savings. Designing an amplifier to work on these voltages would be quite difficult, and they do it. They do have transistor amplifiers that operate on plus and minus 100 volt rails. So the way this works is when the signal is low, Q2 and Q3 are your driver transistors, Q6 and Q7 are your outputs. When you have a low signal here, these 4 transistors work as class AB, and then when the signal increases to the point where this kicks in, Q1 and Q4 kicks in, and then that turns on Q5 and Q8, and that creates the higher voltage and the higher output power. And it's done instantaneously. They have these blocking diodes in here to keep this from backfeeding each other. This supply won't backfeed here, and this supply won't backfeed here. That's why they have these diodes, to prevent that. Yeah, so it sounds complicated, but in practice it's pretty simple. My only concern would be, how would you get this all to work with low distortion? And I guess they have it figured out. So it would all have to be biased properly so that these transistors are turned on perfectly to the point where they only come on when they're needed, and the transition from this to this transistor or this to this transistor is seamless and distortion free. So let's have a look at the amplifier itself, and let's start working on it. Alright, so here's a look at the amplifier module itself. It's all self-contained. It's got 4 devices. Nice large heatsink. It's pretty massive. It's got some weight to it. It's got some mass. And then there's a little card on here that handles all the driving input signal. Input signal's over here. This little 10 microfarad cap, that's our input blocking capacitor. And that is right here at the input. So we'll change this one out for an audio grade capacitor. Let's go through and do a recap. Let's take this apart. Okay. And there's our transistors. We can put this aside. A little bit of a heat zone in this area. Looks a little darker than the rest. And that coincides with these transistors. Don't see any cracks, which is good, considering they do have these connectors, and these connectors will crack and fail. This would be where you take your bias measurements, and I believe that goes across this resistor here, just one resistor. So let's chuck this thing up. Hold this in place, and we can start. This one's 150 volt. It measures 102 microfarad. It's got 880 milliohms of ESR, and it should have probably somewhere around 300 milliohms, not 800, so it's a little high. That's fine. I'm going to replace them with 100 microfarad 63 volt Nichicons. I got these. What is that on the board? So I gotta say, after working on this Hitachi, I've liked a lot of the printed circuit board. Everything's marked for polarity, marks part numbers. It's a real treat to work on, especially when you come off of one that has no markings whatsoever, and makes it that much more difficult to locate part numbers and what orientation they should be in. This thing even has the transistor orientation and collector base emitter, so it's all marked on the board. Makes for easy testing. Alright, let's do these two. These are power supply 4.7 at 160 volts. Let's see what they measure. And I haven't seen overly bad caps either. See, this is a 4.7 at 160 and it measures 5.3. It's got about 14 ohm ESR, which should be a lot lower than that. It should be down around 5 ohms or less. And we got 13 ohms. Here, let's try this one. Yeah, this one says 4.9 microfarad, 18 ohms ESR. So these two are pretty much done. High ESR. So what do I have here? I got a 10 microfarad at 60. I think I'm going to upsize these. And these are Mashita caps. Let me test them. They're brand new. Let me see what they say. 9.1 microfarad, and it's got less than 8 ohms. Let's try this one. This one's even better. 6.8 ohms. Let's install these two. Usually what I do is I tack one lead in and then I'll set the cap down flat on the board so it's not sitting up or cocked at an angle. It sits nice and straight on the board, and I screwed that one up already. Okay, there we go. They sit nice on the board. These are 100 volt at 22 microfarad. Got two of them here and one down here. Let's take these out. Typically what I'll do is I'll go through and I'll do all of the one value of caps. If there's like multiple caps of the same value in voltage, I'll pull them all out at the same time. If there's 4 or 5 or 6 or whatever. And then I'll replace all those at one time. And that avoids confusion as to the value and where did this one come from. And I typically don't draw out any diagrams. I just check the board for correct orientation when I pull the cap out, and then I just follow the board. If I see any discrepancies, then my alarms are raised, and I won't take the board for granted if I see any discrepancies. Let's clean these holes out. Okay. Didn't check these yet, did I? .24 microfarad, and it's got 2.8 ohm ESR. The ESR should be down below 2, and it's a little high. Try this one. .5, and we got 2.9 ohms ESR. It's no good. Oh, we got 25.7 microfarad, 2.6 ohms ESR. So they're showing their age, that's for sure. Let's put these ones in. These are Mashishita Panasonic caps. Okay. All right. Another thing I don't do is I don't clip the leads till after I'm done. And that's a safety thing for me, because if I see the leads clipped, I assume it's not been changed out, and I might just pull a cap out. Alright, so we got our 10 microfarad up here. Come on. Okay. Alright. Now for these I have these audio grade, these are Simac 2s from Elna. And it's 10 microfarad, 25 volt. Audio grade, that's what's going in. If it was a smaller value, I'd probably be putting a film cap in that position, because that's where I think they shine the best, is in the audio path. And I know there's lots of controversy about film caps. I'm a believer that film caps are better than electrolytics in a lot of ways, and they have a longer life, they have better stability, better accuracy in value. So there's a lot of pluses in using a film cap, but I'm not going to get into that discussion right now. And the last one, I think, is this one here. This one here is a 47 at 63 volts. Let me see what this one measures. 49, and it's got a 2 ohm ESR. That cap's not too bad. I didn't check that last one. Ten at 25. This one measures 12.1 microfarad, and it's got a 5.2 ohm ESR, and that's about right. It's a little off on the value, quite a bit off on the value, but we're going to replace it with this here. I'm going to use this here. This is a 47 microfarad at 16 volt. This is a bipolar Muse cap from Nichicon. It doesn't need to be bipolar, but it let me see here. Let me see. I was going to change. Yeah, I'm going to go with this cap. Just because I don't have anything more suitable at the moment. Have to put an order in for caps. Okay, I think we're done. Let me check. That's it for all the caps. 2 here, 1 here, 1 and 4. Alright. So I'm going to go through and check some of these resistors. Some of these resistors here. And there's a carbon comp down buried inside there. I never trust carbon comp resistors. I don't know if you can see it. It's right here underneath. They are notorious for drifting out of value. I'm going to check a lot of these resistors just to make sure they're all 100%. And then I'll give the back of the board a clean. I still want to test gain on some of these transistors, especially these ones that were hot. I might just pull these 3 out and test their gain just to make sure that they haven't been cooked. And we'll go with that. But I want to check all these resistors, make sure that they haven't drifted, the power ones especially. You know, if they've been stressed with heat or voltage, they may have changed. So let me go through that. This is our long-tailed pair here, I believe, right here, these two. And they're fairly close together. So I'm just pulling this apart here. These are, what are these? These are Q703, 704, 705, and on the schematic, 705, 703, 705, 703, or 704. Doesn't show 704. Oh, here, 704, 705, 703. These 3 transistors here. Okay, these transistors. Look at the heatsink insulator on this. It's completely destroyed. It's almost like it got burnt from heat. I've never seen that. That's not mica. I don't think it's mica, because mica doesn't burn. Mica is a mineral element. That is plastic of some kind. It's all burnt. Transistor looks fine. This heatsink compound's all dry and cakey. But this here is really weird. This is... And that was it. There's no other insulator. So that's amazing it didn't burn through and short. Let's try this one. Maybe I need to replace all these insulating pads because if they're plastic, that's no good. They deteriorate with high heat. Let's see what this one looks like. I have a feeling it's stuck on. Oh boy, that is really stuck on. Let me see if I can knock this free. There we go. No, I knocked the other one free. There we go. This one's mica, and this is perfectly fine. That was really weird. That one didn't have a mica washer on, I'm guaranteeing you that. Let's try this one. This one fell apart and it wasn't stuck. But yeah, this one's mica as well. So these two had mica washers. This one had a plastic washer that failed. I don't know how that happens. Okay, well, we'll fix that all up. Just want to check the gain on these transistors to make sure that they are still good. Take that off and take that off. Alright, ran into a little problem here. These 8 transistors here are all the driver transistors for both amplifiers. There's 2 NPNs and 2 PNPs for each amp. Okay, now these are complementary, right? All these PNP transistors test fine. Minimum HFE for these is 60, and we've got everything is above 60. This is the lowest one I got is 86. Highest one I got is 126. So these are okay. They're not matched, but whatever. These 4 is another matter. 3 of these have failed to meet minimum HFE. These 3 here, and then this one actually meets it, but just barely. So what I want to do is I want to replace these 3, but you can't just replace 3 transistors. You have to replace the complement for them, and might as well just replace them all at the same time. So these are kind of difficult to match and substitute because they're high voltage transistors. They're 160 volt VCBO and 1.5 amps collector current, and it's a fairly high voltage transistor, and you know that you don't get high voltage transistors very often. These are my closest match, and I have enough of these. I can put these in. These are 2SC2073s from onsemi and 2SA940s from onsemi. These transistors will work. The problem is these transistors are rated 10 volts less than these ones. These are 160 volts, these are 150 volts. I have a feeling it's not going to make a hell of a difference, and it's not in this application. I think it's going to work just fine. So we're going to plug these in and we're going to see how it goes, and we'll put all new driver transistors in just to because these 3 here are bad. These 5 are good. So to fix this, we're just going to put 8 new transistors in and call her a day. So these insulators they used are a mix. This one's plastic. If you can see that. Here, I'll show you. I'll burn it. See how it burns? Mica will not burn. Here's a mica washer. It doesn't melt. It gets hot, but it doesn't melt. So I'm going to replace all of these insulators. These are, I think these are all plastic. Some of them are mica and some are plastic, so I don't understand why it's all mixed up on the amplifiers. I'm going to use sill pads. I have a bunch here, the gray ones, and we'll put those on. Perfect for TO220. See, this one's plastic too. All these are plastic. 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 Let me get rid of these plastic ones. So this is the other amplifier for the other channel, and I pulled this PNP transistor off, and it's burnt like the other one was. You can see it's completely burnt. Plastic insulators are no good, so I'll have to clean this off. Just doesn't like the heat. I don't know why they used them. and the compound is all dry. It's like, so we see a lot of heat here, and just gonna clean this all off and replace these. This is, yeah, this is, look at that, burnt right through. All right, just going through and reworking these heat sinks. I took them all apart and washed them with soapy water, like dish soap. You don't want to use anything corrosive on aluminum. And the reason I did that is because there was a lot of dust in the fins that you can't, even the air compressor wasn't taking the dust out. It was kind of stuck there, so I just decided, okay, wash them. And to do that, I had to remove the transistors and all the pads and everything else. So I'm going to reuse the pads. Here they are. I'm just going to clean them up. They're all in good shape. And then we're going to put the transistors back on. These are all original transistors. Hitachi transistors, 2SB722 and 2SD752s. And I've been measuring gain on them. They're all pretty much in the ballpark with each other, so that's all good. Everything's good that way. That can all go back together. The boards themselves, let's see what I did here. This one had a bad resistor. There was a carbon comp resistor down underneath here that was out of tolerance. It was a 150K resistor and it measured 170K. I got all new capacitors on the board. 4 new transistors, driver transistors on this side, and using silo pads for heatsink. Cleaned the back of the board. Everything was defluxed and resoldered. The resistors were all checked, and that's where I found that bad resistor. Caps, well, nothing to say about them, they've all been replaced. So that one's ready to go. This one here, same thing. Tested all the resistors, they were all fine. Actually treated these pots too with fader lube, and 4 new transistors on this one as well, new caps, cleaned and defluxed. It's all going to go back together now. So as soon as I get this pasted all back together and tightened down, assembled, I can put these back into the receiver. My caps came in today, so we're going to put those in. These are the new capacitors for the main filter, and we're going to put those in. And then we're going to be getting pretty close to the end. Do I still have to do the tuner? Alright, so both amplifiers are complete and put together. I'm ready to get dropped back in the receiver. Now I gotta say, this is, I stumbled upon a few things here when I was working on this. It's just so happened I installed a couple of caps backwards. And good thing I went through and made sure I double checked everything. I wanted to make sure I double checked everything because pulling out, these boards are not identical, right? They are actually mirror images of each other. And you see if I put them next to each other, they're mirror images. And wanted to make sure that you had the correct transistor in the correct location. So that's why I double checked everything. And then I went over my capacitors as well. And I had one of these 10 microfarad at 160 volts in backwards. And that cap's right across the 100 volt rail supply. That would have gone pop, fizz, bang. It's a good thing I caught it. The other cap was an input capacitor I had placed in reverse. It probably wouldn't have done anything, but it probably would have messed up the sound on that one channel. Now that's sorted. I actually had this board on this heatsink and this board on this heatsink until I realized when I was plugging in the output transistors that something wasn't correct. So I started going through, confirming all the connections and the transistor locations. And this isn't very clear. It has A10 and A9 for these two connectors for these transistors. And if you look here, this one says A11 and A12, okay, which is the right channel and the left channel, I think, right channel. This one has A9 and A10, and I had to make sure that A10 was all of the NPN transistors, and if I flip it over and have a look, a peek inside, I can see the two NPN transistors. And I had to make sure that they were wired correctly because they weren't. And if I would have plugged it in, it would have been big bang smoke, and be putting a parts order in. Okay, so for filter caps, these are screw terminals, obviously. So they're going to have, you've got these M5 screws and washers. So what I did is I desoldered the wires off the old cap and soldered on ring terminals, and then I heat shrink them with color coding so I know which one's positive, which one's negative. And now it's just a matter of unbolting the old cap and inserting the new one, and just connecting the wires up, and it's done. It's pretty simple. Did the same up here. Got the ring connectors, and hopefully the wires are long enough. They should be. I didn't cut them, I just unsoldered them so that I preserved the wire length. And just don't want to make any oopsies where I have to start replacing wires because they're too short. So now I just roll this around the other way, unscrew it, take the screws out, take the clamps off, replace the cap, put it back together. Alright, so I just finished checking contact resistance on all 6 of these contacts, and they're all high. Anywhere from 3 ohms up to several hundred kilo ohms. So I'm going to do polishing of these contacts, all sets of them, and these are going to go back in. These are the speaker relay switches, and they came out of that board there. And once I could clean it back up, put it together, I think we're going to be ready for our first power up, because I'm done the tuner. Tuner's completed with new caps. Just got to put it all back together, and then we can, yeah, like I said, power up. Alright, I'm ready to do my initial power up. Now there's a few things I'm going to do to prep for this. I'm only going to start one amplifier up at a time. I got the top one here connected. This one is disconnected. I also have the soft start circuit defeated and bypassed, so that's going to be going straight to full power. And I have speakers connected and a source connected, a signal source. I am going to bring this up on a variac. Let's see here. Yeah, I'm going to bring this up on a variac, and maybe we can watch a smoke show, or hopefully there's no smoke show. And I'll bring it up slowly, watching the current. I have a meter here connected across the emitter resistors, and this will show us if there's any excessive current, and if there is, we'll shut it down right away. So let's turn this on and then start ramping up the voltage here, and I'll watch our pilot lights. We don't even have pilot lights. Power switch is on. Okay. Unless there's something disconnected. Let me check. Oh, sorry, I didn't have the power switch on. I had another switch on. So let's do that again. Power switch on. I don't know if you can see the meter and the amplifier at the same time. I'm going to try ramping this up slowly. Heard a click. Full voltage. Full voltage, and I'm showing about 20 millivolts here. Everything seems fine. We still don't have our sound though. Our protect relay did not kick in. So I'm going to say that amp's fine. It's not drawing excessive current. Relay cooked out. Not drawing excessive current. So I'm going to bring this amplifier online too. I'm going to plug this one in, and then we'll do the same ramp up, and we'll see if this thing comes out of protect. with both amplifiers powered up. Okay, this amplifier is connected. We're going to do the same thing. We're going to ramp up. I still have this meter connected to the top amplifier. Let's move this down to the bottom amplifier now so we can monitor this one. This is going to measure the plus minus 100 volt rail. So let's turn this thing up already. Looks like we're getting voltage already. So let's go for it. Watch the current meter. I don't see any movement. There's our soft start coming up to full voltage. Looks like we got more current on this channel. Okay, so we're going to keep going. It's full voltage. I'm going to take it down a bit. Still don't have any relay protection kicking in, so we might have a problem to solve. Let's shut this down. You pull a speaker for this channel. Actually, let's measure that. Let's measure the DC offset on the outputs. So we've got a pink wire and an orange wire. So let's go back here and connect up our meter. Let's find a good ground. Here's the pink wire. Find a ground. I need to find a ground. Right here. Okay. Let's see what we have now. Let's bring this amplifier up. It might have a fault in it, I'm not sure. Soft start. Oh, I heard another relay click. Their tone, very quiet. I wonder. Might have a switch that's out of position here. Let me check all these switches. I'll be right back. And I believe I figured it out. There was one switch that was pushed in. Here's our tone. Left and right. Everything's working. Bias adjustment. Okay, great. Let's set up the bias. And let me shut this off. It's all working, so we don't need to use the variac anymore. We can just run straight power. So let's set up the bias, and then we'll get on to a power test here. Everything's looking good. Alright, we're going full on, no protection. It turns on. Jumped up to over 100 watts. Settled back down around 85 watts. And we have lots of millivolts here. Let's turn this down. Just going to let this idle for a while I go look up the value. Here's our wattage, 72 watts. And I think if I turn this down some more, it drops even lower, but I'm not going to turn this one down. Let me go look up the value I need and then we'll come back and set it. Alright, so our value for bias setting is 11 millivolts, plus or minus 4.4 millivolts. That seems odd because 11 millivolts isn't very much, but they have a really wide range. So 4.4, that could be considered within spec. But I'm going to turn this up to about 10 and leave it there. Get it as close as I can. Anyway, maybe 9.5 is going to do. See, and then it jumps over. Let's leave it there at 10. Okay, let's do the other channel. What we got here? We got a nothing. Let's turn this one up to about 10. Okay, so we are consuming 63 watts. I'm going to let this sit for 15 minutes. I'm going to monitor this, make sure it doesn't drift too far. If it does, I'll retweak them. And then we'll get on to a power test. Alright, so they're all wired in to do power test. I'm going to do 8 ohm load. I'm not going to do full 10 minutes because I don't want to burn things up here. I'm just going to do maximum power and then we'll move on to our square wave tests. I have a feeling this thing's going to perform really well. So let's got everything connected and let's turn it on. Here we go. Clicks on, settling around 70 watts, 75 watts. I have a feeling that will go down with what's at 75 now. I have a feeling that will go down with heat. So let's turn. Why don't I have any sound? Oh, I have to engage. For some reason, these other two relays are not clicking in. There we go. What is wrong with those relays? And C won't go either. I'm going to have to investigate this because this is not working properly. I can't, the switch relay A for system A works, system B works kind of, system C is not working at all, the relay. I wonder if that's dirty switches. Could be dirty switches, so I'm going to have to get into that. Anyways, we know it's working. Let's turn off our speakers, turn on our output, and turn up the volume. Here we go. Okay, we got a lot less on one channel. Is our balance set right? Or do we have something going on here? Let me try this. Oh, I got a different scale, that's why. Alright. Sorry about that. Okay, let's go up. Right about there is clipping. Actually, I'll back it off a little bit. Right there. And we got 47.98 volts RMS on the output. Just going to hold it here for a while. And my heatsink on my load is getting quite hot fast. Let's turn this down. Did really well on the full power. Okay, let's turn it down. Let's turn down the power. Let's do square wave. Okay, here we go. That's our square wave bass cut. Our tone controls are turned off. There we go. Bass cut. Bass boost. Defeated. Okay. Mid-range boost. Mid-range cut. Okay, treble boost, treble cut, okay, treble cut, treble boost. See the effect of the hinges in tone defeat. Balance. Okay, let's go up in frequency here. 7, 8, 9, 10. Kind of unusual. Let's turn it down a bit. 5,000 hertz. And we're losing it right around here somewhere. It's 19 kilohertz. Looking more like a square wave. So the rise and fall times are kind of slow on this amplifier. (5,000 kilohertz or 5 kilohertz right there? Not doing too bad. There's no heat on the heat sinks here at all. They're still cold. This, on the other hand, is radiating quite a bit of heat, my load. So I'm quite pleased with how this worked. We still need to repair the speaker relays because they are not behaving properly. I'm going to check and see if the switch contacts are dirty, or I just had these relays out and cleaned them, so they're working 100%. I know they are because I applied power to them, but it has to be a switch problem. But then when they tap it, I wonder if it is a relay problem. And the C channel doesn't work at all. I don't see it clicking in. A works. investigate that. Alright, so here's the protect circuit. This is the protect relay right here. Protect relay right here, and this transistor that drives it. Now, I got no problem with the protect relay kicking in and out. That's working. What I have a problem with is these other relays that are switched in. They're showing up here. Let me get rid of this. They're showing up here. These relays. These relays operate the contacts for the A, B, and C sets of speakers. Now, what these we were pulling in, one was pulling in okay, one was pulling in really weak, one not pulling in not at all. So I checked the voltage across the coil of these relays, and I'm getting about 6 volts of potential across them. And these are 12 volt relays. Right here, you can see it's fed with 12.4 volts, and that goes to the coil of each relay. Okay, and then there's the back EMF diode here for each one, and then it goes down to a switch, the switch bank, and then it goes down farther. So let's look at this. This transistor here was a 2SC1213, and I replaced it with a 2SC2240. Now I did that because I figured, okay, well, this transistor's acting like a switch for this relay. This is a 12 volt relay. I made an assumption, 100 milliamps, that should be plenty. The 2SC2240 is good for 100 milliamps. But what I didn't take into account is it's not just this one relay, it's these other relays, because this line goes up and it powers, actually it acts like a sink for, to this is ground, so this turns on, and then the power flows through. This switch also controls 2 more relays up here, and so I measured 6 volts across those relays, and I measured 6 volts across this transistor. This transistor right now is really overloaded with current. I didn't realize there was that much current, so what I'm going to do is take out this transistor. It's a 2SC2240, and I'm going to replace it hopefully with a 2SD882, which is one of these here. It's a different case style, handles way more current, handles up to 3 amps, and it's got a gain of about 150. It should have no troubles switching those relays on and off. This is designed to switch relays and as a power amplifier. So this transistor, I'm going to put it in place and see if that fixes my problem. Alright, so I replaced transistor Q553 with a 2SD882, and it fits in there really nice. And now it's working. I'll show you, hopefully, if I can show you. Pull this thing, and I think you can see the 3 switches here. Okay, so 1, A is on, B is on now. Take A off and turn C on. If I turn A on, now it shuts off. So it's all working 100%. And then the protect light is not anymore, because that was a problem before too, because the voltage drop was too high. It was triggering the lamp circuit. So it's working 100% now. Pleased with that. So I'm just going through and doing rebiasing, because I must have obviously knocked one of these potentiometers way out of whack, and the power consumption skyrocketed. I was over 75 watts now, but I'm back down to 66. So these are very touchy. So I put a dab of silicone just to lock that in place there. Just setting it, and I'm just going to let that silicone cure, and that should hold it there, just so that it doesn't go crazy and self-destruct. But everything's working great. I tested all the functions. Everything's 100%. So this is going to go on the listening desk now, and I'm going to give it a good listen to for a week or two, maybe 2 weeks. I don't want to return it too quick, because a lot of extensive work was done, and you never know, something might crop up in the future that maybe I goofed up or maybe something failed. The problem with the speaker switches and the protect lamp, that was my fault. I put the wrong transistor in. I should have done my homework better on that one. I assumed that transistor was only switching one relay on and off, which is fine doing, but when you click on two more relays, the load is too much for the transistor. The transistor actually got really hot, and it was sinking current and about a 6-volt drop across it. So I'm surprised it didn't blow up and short circuit, but I think we got the right transistor in there now, and it's all working. So I have full control over all of the relays. All right. Anything else to say about this? Yeah, well, there was a lot of parts went into it, a lot of caps. I removed a lot of bodges. I'm going to take out the bodges and show you all the bodges I removed. Alrighty, here's a look at the parts I put into this thing. 24 small signal transistors. These are the black leg variety Hitachi transistors. They're mostly 2SC 1344 and 1345. Now these are on my list, and they're known to go bad. Now surprisingly enough, I tested all of these when I pulled them out, and they were all okay. They had a gain range between 400 and 550. The ones that were still perfect were still up in the high range, 550 or 520. But the ones that were starting to slip, there were some in here that were around the 400 range. So none of them failed, but all of them were working. But still, they drift over time, and the gain can change, these black leg monsters. 8 driver transistors, 4 for each channel. I found one that had a slipping HFE, so I decided to change them all. Probably could have went and done more transistors than this, but I think this will balance it out and make it work good. Now caps, for the most part the caps are okay. These black Nippon Chemicon caps are really showing their age. They're growing in value, which a cap shouldn't do. It shouldn't grow in value as it ages, because that's internal leakage. And the ESR slipping on a lot of these. A lot of them held up fairly good, but I think overall, I think recap was a good thing, because it brings all the caps back to their correct values and their correct ESR, and the receiver can start to perform again like the way it was intended to. These two main filter caps, these are for the low voltage rails. They say they're 18,000 microfarad, but they measure around 13,000. So I opted to replace those, and I got a pair of Vichy, nice brand new ones, 22,000 on both, and this thing will sing. A couple transistors or resistors I found out of tolerance. Those are bad. These are all the bodges I removed on the back sides of the boards. I removed these and replaced them with a chip resistor or a chip capacitor, depending on what it is. And this is a huge thing for me. I like to see clean boards, and if I see bodges on the back, I try and remove them, in such a way that they just disappear. So removed all these resistors and caps, replaced them with MLCCs or chip resistors, and they virtually disappear on the back of the board. You don't see them anymore. The function's still there, but it just cleans it up a whole lot. And then I guess the big story for this one, if there is a big story for this receiver, is the heat sinking pads. So these are mica, but then some of these are plastic, and these are garbage. Too much heat I saw on 2 of these, too much heat just totally cooks them and turns them black, and they turn to carbon, and they fail. Well, obviously they fail, and then what you get is either a short circuit or you don't get proper cooling on your device. So they're all gone. I replaced that all with sill pads throughout the unit, and got rid of all these garbage pads. And that's about it. Okay, well, that's it for this one. I'm going to wrap this up here. It's a nice receiver. I really like it. I wasn't pleased at working on it. It's kind of a beast to work on, especially those long boards. They're like 14 inches long, and then there's 100 wires on them. You have to just start on soldering to get behind the board and get parts on it. It's just, it was kind of a nightmare that way. But I'm glad it's all done. I got it all finished, and they're going to enjoy listening to this one for the next few weeks before I return it. And then on to the next, so stay tuned. We got lots of stuff coming up, lots of interesting stuff. So take care, and we'll talk to you on the next one.